I will not talk very long at all. It might be 5 minutes. So pay attention for the 5 minutes I talk to you. All right. Today, just like side, 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 and side, angle, side, we have this thing called angle, side, angle. If you know two angles and the side in between the two angles that we're talking about, then the triangles are congruent. So two angles and the side in between. Two angles and the side in between, these triangles are congruent. So why would ABC be congruent to DEF? Side or angle, side, angle. Angle, side, angle, because we know two angles and the side in between. Okay. Technicians install cables from a cell phone tower to the ground to pass inspection. Both cables must be the same length. Does this make sense? Okay. Are the cables going to be the same length in this situation? If these are both 52 degrees, and if you have a 90-degree angle on this side, what should you have on the other side? 90 degrees. And from here to here, what do you know? Is this distance going to be the same for both triangles? Yeah, that's called the reflexive property, and we're going to get to the reflexive property when we start doing proofs. When they share a side, it's the reflexive property. It's the same for each. So all of a sudden, I have angle, side, angle is congruent to angle, side, angle. So then by angle, side, angle, these two cables have to be congruent because they're corresponding parts of congruent triangles that are congruent. All right. Are these two triangles congruent? Yeah, why? Angle, side, angle. So since these two triangles are congruent by angle, side, angle, then 3x plus 23 equals 5x minus 29. Now, 3x plus 23 equals 5x minus 29. What do I do to each side? What do I move first, Caden? Subtract 3x. Good job. So 23 equals 2x minus 29. Cole, what do I do to each side now? Add 29 to each side. So you get 52 equals 2x. And then what's my last step here, Albert? How did I get x alone? By 2. Divide by 2 on each side. X equals 26. Okay? Now, besides angle, side, angle, I have angle, angle, side. If you have two angles and some other random side, that's enough to say triangles are congruent. So two angles and some other side. So, these two, why are they congruent? Is it side, 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 angle, side, angle, side, angle, 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 side? Angle, side, angle. Because we have two angles and the side in between. What about these two? Side, side, side. All three sides of one, all three sides of the other. What about these two? Not angle, side, side. You can't say that. That's a naughty word. You know two angles and a side. So it's angle, angle, side. Angle, angle, side. Not angle, side, side. Okay, what about this one? This is side, angle, side on this one, but is it side, angle, side on this one? No, these are not congruent. Congruent. Okay, that doesn't work. Okay, all sides and angles of ABC are congruent to the corresponding sides of these. Are these two objects going to be congruent to each other? And the answer is yes. Anything that has all its sides and all its angles congruent are going to be congruent to each other. All right, so these are the two new theorems today. Like I said, it would be short and sweet. The assignments out there, get to work.